Hi, my name is James Chu from Renaissance Timing University, and today we're going to learn about frequency error calculations. We're interested in frequency error calculations because we're a timing company. So naturally, we'd like to know about the stability of a signal or how much it drifts over time. Take, for example, a crystal. A crystal can drift about plus or minus 50 ppm over its lifetime. Something even more accurate than that would be a TCXO or OCXO, which can drift by plus or minus 5 ppm over the lifetime. Even more accurate than that would be like a sync signal, which is plus or minus 1 ppm over the lifetime. Now, to calculate the stability of a signal, we're looking for something called fractional frequency offset, or FFO. To calculate the FFO of a signal, we look for something called ppm, and ppm stands for parts per million. To calculate the ppm, you take the actual frequency minus the ideal frequency divided by the ideal frequency multiplied by 1,000,000. Now, if you take a look at this equation, it looks very similar to something we already know. It's called percent. And percent is basically you take your value divided by your total value multiplied by 100. But in this case, for parts per million, we're multiplying by 1,000,000. Now, we can expand this to something called ppb, which is this exact equation, but multiplied by 1,000,000,000. Or you could expand that even more, parts per trillion. Same equation, but multiplied by 1,000,000,000,000. So let's take an example to calculate. Say we have a frequency of 99.998 megahertz, and the ideal frequency is 100 megahertz. So what is the fractional frequency offset? What is the ppm? So to calculate that, we take 99.998 megahertz, subtract 100 megahertz over 100 megahertz. You'll notice that the units cancel out, so ppm is actually unitless. And when you calculate this, you'll get minus 20 ppm. And so if you take a look at a crystal data sheet, for example, you can look at crystal tolerance or crystal stability. And basically, it'll tell you what the drift is in ppm. Thank you.